Hello and welcome to Miss Ma's Advanced Functions class. This is 9.7, Modeling with Functions. So basically you're going to be given a real life situation and you're supposed to figure out which equation or which function would best match that particular situation. We learned a lot about functions in the whole course, and so you're going to have to be able to recognize when each of them is applicable. So let's look at this question. Approximately 5,000 people live in Brandon's town. One person in his school came back from March break from Florida with the virus. A week later, 70 additional people had the virus, and doctors predicted that around 8% of the town's residents will eventually get that virus. We want to model the number of people infected as a function of time in days. Okay, so if we were in grade 9, the only thing that we could do is use a linear equation. So we're going to try it with the linear. So of course this is y equals mx plus b, and we can just start to fill this out. We know that it starts with one person, so b is equal to 1, that's the y-intercept, the initial value. And we also know that after a week, so when we have 7 days, we have 70 additional people who are infected. You got to watch out for those special words like additional, or if it wanted the total, we would have total people. So in 7 days there are 71 people who are infected. So we do have two points here. We've got 0, 1. We've also got 7, 71. So we can find the m value. M is equal to delta y over delta x. So this is going to be 71 minus 1 over 10, oh sorry, over 7 minus 0. I was just jumping ahead of myself. So I get 70 over 7, which is 10, and that's the slope. So y equals 10x plus 1, that's the general equation. Of course, it does say that it only applies for 8% of the population infected, so we do need to figure out what that is. So 8% of 5,000 people, I believe, 5,000. You type that into your calculator, 0.08 times 5,000 is 400. So we want to figure out when exactly that is so we can limit our equation. So 400 equals 10x plus 1, and we're just going to solve it. So 399 is equal to 10x, and x is equal to 39.9. So we're going to limit this equation for x in r such that 0 is less than equal to x is less than equal to 39.9 days. So there you go. Now of course this is not exactly the best way to model this situation, since if it was going to be an infection, that's probably going to be growing in an exponential fashion, right? It's probably not going to be growing in a linear fashion. So the issue with this one is that it's just not the proper growth, right? We expect it to be a little bit more of a jumping growth rather than just being a nice linear straight line. So let's try to do it with an exponential function. So using the exponential function, which we would say is y equals ab to the x, where a is going to be the initial value. So we're using the same points here. We've got 0, 1 and 7, 71. It's the same exact question. I'm not going to read it again for you. So we know the initial value is a is equal to 1, and so we're going to have to figure out what b is. So let's fill that in. 71 is equal to 1 times b to the x, which is 7, and so we get 71 divided by 1, that's 71, and we want to get rid of the to the 7, so we're going to go to the 1/7 is equal to b, and so that is approximately, using your calculator, 1.84. So our equation is y equals 1.84 to the x, and that's a little bit more reasonable, but we do have to consider that upper limit. So again, we're going to solve for it. So 400 is equal to 1.84 to the x, and so we just have to solve that using logs. Log base 1.84 of 400 is equal to x, and so x is approximately equal to 9.84. So again, we would just write the limitation in here. X is in r such that 0 is less than equal to x is less than equal to 9.84. There we go. So that's the general equation. Now the problem with this type is that we've actually got the correct growth, but we can't really build in the limit on the growth, right? Limit is not built in. So what we need to do, and if you look at this type of growth, it actually usually slows down. So we actually kind of want to have something where it looks like it's slowing, the growth is slowing down and reaching its capacity. That's what we call the carrying capacity. So it has to have an exponential and then sort of even out. And we know that this equation is just going to look like whoop and just go off into infinity. And so we're just basically just cutting it off and being like, nope, no more, right here. So we don't want to have that that sort of weird limit. We're going to actually introduce a new function, which is called the logistical function. Now the logistical function is, just like I said, it's got this shape to it. So it looks like this, and it has a carrying capacity. So it actually has two asymptotes. It's got y equals 0 as its asymptote, and it's also got whatever the carrying capacity is as the asymptote. And it's a composition of functions. So the logistical function is y equals c over 1 plus ab to the x. Now c is called the carrying capacity. So in our case, the carrying capacity is 400. That's the most that can be infected. So C is equal to 400. And a lot of people here will say, oh, A is going to be the initial value and B is the growth factor. And that's not true. This is actually a different, it works in a different way. So we're actually going to have to find A and B on our own mathematically. So again, we're using 0, 1 and 771. And we're just going to fill this in. So 1 is equal to C, which is 400, over 1 plus AB to the 0. And so you can see B to the 0 is actually 1. So we're going to get 1 is equal to 400 over 1 plus A. And now we can just solve for A. So 1 plus A is equal to 400. And so A is equal to 399. And now that we have that, we're going to be able to plug it back in to the equation and find the answer for B. So using the same equation, 71 is equal to 400 over 1 plus 399 times B to the 7. And so we can just actually cross multiply. So this is going to become 400 over 71 is equal to 1 plus 399 B to the 7. So B to the 7 times 399 is equal to 400 over 71. I'm just doing the algebra. And sorry, I'm just flipping back and forth. It's just because of space. And I do like to keep my equals signs all lined up. It just is better form. So we get B to the 7 is equal to 400 over 71 minus 1 over 399. And so B is this to the 1/7, and if you type it into your calculator, you should get about 0.53. So that's the answer. Okay, so now we can write our equation here, and we don't have to worry about any x value being limited or anything like that, because we do have the carrying capacity built in. So y is equal to 400 over 1 plus 399 times 0.53 to the x. Okay, you can see that this is not the initial value and this is not the growth factor. We did have to find it based on the equation. Okay, and in terms of issues, there are none. So hooray. I mean, in some ways it's a little bit more difficult to find, but not really. I mean, you can just fill it in, especially if you have the initial value, then your life is much easier. So anyways, that is about it. All we did was take a situation and decide which equation would best model it, and we learned about the logistical equation, which is y equals c over 1 plus ab to the x, which looks like this. And that is all. I hope you enjoyed it. Bring any questions you have to class, and I will see you soon. Thanks. Bye.